So if you want a 0 at the end of anything, your prime factor should have a 2 and a 5, both of them, right? 2 and 5 both should be there. But when you do a factorization of 6 to the power n, you know that it is 2 into 3 to the power n. That is 2 to the power n into 3 to the power n. There's 5 missing over here. There's no 5. So if there is no 5, you cannot have a 0 at the last of the digit. Okay. Okay, sixth question. Can you explain, anyone? Why is this a composite number?
As it is having two other factors.
Yeah, see, 7 into 11 into 13 plus 13. So of course you can take 13 common and you can write it as a factor of two numbers like 7 into 11 plus 1. So 13 is a factor of this number, whatever you do. Other than 1 and the number itself, at least 13 is going to be one of the factors, correct? Nitish, can you explain this? You did this one, right?
Yes, sir.
How did you do? Tell me.
Sir, I took 13 out, sir. Common factor.
Yes. So 13 is a factor of this number other than the number itself and 1. That's why this is a composite number. Same way, here also you have this whole thing plus 5.
5, sir.
So in this you see that both these terms, this term and this term, they have a 5 in common. So you will take 7 into 6 into 4, 3, 2, and plus 1. So 5 is a common factor for this number again. That's the reason this will also be composite. Okay. Is everyone okay with question number 6?
Yes, sir.
Okay, 5 and 6 should be simple. What about question 7? Those of you who have not tried, just give it a try quickly. Read the question and see. Okay, so have you gone through the question, guys? Do you know what needs to be done for this?
Find the LCM.
Okay. LCM of what?
The time taken by Sonia and the time taken by Ravi.
Okay. So they're saying that there is a circular path around the spokes field. Sonia takes 18 minutes to drive one round and Ravi takes 12 minutes for the same. So suppose they both start at the same point and at the same time and go in the same direction. How many minutes later, after how many minutes will they meet again? So is that true? Is it the LCM? Of course, right? The number which will be common multiple of both of them. That is where they will meet for the first time once more. LCM of the two. Is that true? Everyone understands? HCF? Will they meet after if one round takes 18? Yes. See, one person is going faster and one person is going slower. So if both of them start at the same time, where are they going to meet? What guys? Do you understand? Is it LCM or HCF? What do we have to do here?
HCF, sir.
Okay, let's do the HCF.
Sir, LCM only, sir.
Yes. Let's see. Let's try to solve this problem by finding HCF and LCM both and then try to understand what's happening. So there is a circular path, right? And they both start at the same point at the same time. So let's say this is your origin. This is where they start. One guy takes 18 minutes to complete. The other guy takes 12 minutes to complete. Okay. So if you find the HCF, what is the HCF of 18 and 12?
6, sir.
6 is the HCF of these two. Okay, imagine that one person is going faster and one person is going slower. So the person who's faster has already crossed. The person who's going slower behind him, do you think he will be able to catch this guy again in 6 minutes itself?
No, sir, it will take more time.
No, sir. It
So
will
this,
take more time.
the slower guy will never be able to catch this faster guy. In reality, what is going to happen? This slower guy will keep on going slowly, very nicely, happily, he will go slowly. So he would have covered some distance somewhere, but the faster guy who is going faster would have completed one round and then caught him back on the way around the other way around. Do you understand what I'm trying to say? The person who is faster will catch this slower guy once more after completing a round. Is that correct or not? So it has to be the common multiple of both these numbers, 18 and 12. You have to find the LCM of 18 and 12. Find it out. What is the LCM of 18 and 12?
36.
36.
So 36, sir.
36 minutes. So what would have happened in 36 minutes? In 36 minutes, the one person who's faster, that is who takes 12 minutes only to complete this round, he would have gone 3 rounds for this thing, right? He would have completed 3 rounds and reached this place again. And in the same time, the person who's slower, who takes 18 minutes to complete this, he would have only completed 2 rounds and met at this place. So they will both meet 36 minutes later. Does everyone understand why? Confusing? Is this confusing?
Sir, can you repeat it once more?
Yes, I will. Okay. So see, try to imagine this situation. Let's say 2 of you are running, any 2 friends, imagine. One person is a little bit slower. You take 18 minutes to complete this circle. And there is another guy who's faster, or maybe you are faster and the other person is slower, whatever you feel, you imagine like that. And that you take only 12 minutes to complete this round. So since you are running faster, both of you have started together at the same place at the same point. So if you start faster, the other person is coming slower, he's behind you. So this person, slower person, will not be able to catch you up within the same round, right? Within the same, this one round, single round, the slower person, he will not be able to catch you, no? Because you know that you are running faster. You complete the round in 12 minutes, the other guy completes the round in 18 minutes. So you have a faster speed, you're running with a faster speed. Other guy is slower than you. So that person, the slower person, will not be able to catch you up. So what in reality, what will happen? You will go faster. Let's say it is 12 minutes now. You have completed the first round, 12 minutes. Where is the slower guy? He is still behind you, no? He has not completed. He will complete the full round only after 18 minutes. 6 more minutes he needs. So you are here, A is here, let's say the other slower person B is over here. He has not completed. You are still moving faster than him. So you have completed one round. Now you keep going further. You have completed 2 rounds, imagine. So how many minutes have passed? 12 plus 12, 24 minutes have passed already. So in 24 minutes, where is the slower guy? 18 minutes he would have reached here, and 18 plus 6 more minutes, he would be somewhere around here. Can you imagine that? B will be somewhere over here, and you would have completed the second round also again. Are you people able to understand the story?
Yes, sir.
Okay, so now 2 rounds have completed, 24 minutes. Now what will happen? You go on taking the third round. When you take the third round, time is 36 minutes now. And you know that in 36 minutes, you are exactly at this origin, because 12 threes are 36. So you should be at this place. You would have taken completed 3 rounds. You are here, and where is B? B is just reaching this place. He has completed only 2 rounds. 18 twos are 36. In 36 minutes, this B guy completes 2 rounds, where the faster guy has completed 3 rounds. So after 36 minutes, both of them are together at the same place origin where they started. Can you understand this, guys? Is it clear?
Yes, sir.
Okay.
Yes, sir.
Yeah, so all that story is just for your imagination to understand, but for the solving part, you just know that whenever this kind of a situation is there, one guy is going faster, one guy is going slower, and you want them to meet again at some point within the same path, then that will happen, whatever is the LCM of the two numbers. Okay. So in this case,
Sir, and then which kind of situation the HCF is used?
okay, so for HCF situation, I'll think of an example and I'll tell you. Hold on. Actually, there are questions related to that. We will see. I'll give you questions related to HCF also. Okay.
Yes, sir.
Yeah. So in this particular problem, one person was running faster, other one was going slower. When they meet, that happens whenever whatever is the LCM of the two. Now, other situations where you might have to find LCM is, think of, there are bells, let's say 2 bells. There's a bell A and there is a bell B. Bell A rings each 5 minutes. Every 5 minutes, this bell rings. Or let me take some other number like 8. Every 8 minutes, this, yes, tell me.
Sir, your voice is breaking.
Is that so for everyone? Is my voice breaking for everyone?
No, sir.
Okay, that might mean that connection is bad at your end. Okay, check it out. Are you able to hear me okay now? Is it better? Any better? Maybe move to some place where you are getting good signal, because I think speed is okay at my end over here right now. Pragati, are you able to hear me clearly? Okay, so I think Pragati has some network connection problem. Midula, you're also not able to hear me?
Sir, you
No,
are
sir.
audible, sir.
I told she is not there, sir, in class.
Okay, fine then. Maybe she disconnected and she'll join back again. So let's get continue with this example. What I was. Okay, okay. So you're able to hear me better now?
Yes, sir.
Okay, okay. Fine. So what I was telling, I was giving you examples of a bell. Okay, you know, it could be any kind of bell, like a bell which rings in your school or a factory, whatever, some bell which rings. So let's say I'm saying that there is a bell which rings every 8 minutes. This first bell rings. And then there is another bell which rings every 12 minutes. Okay. So if I'm telling you that, let's say that these bells, both the bells started ringing at the same time. So they rang together once. Now every 8 minutes, this bell will ring. Every 12 minutes, this bell will ring. Now, after how many minutes will it happen that both the bells will ring together? So for that kind
Here
of a
also we will find LCM only, sir.
yes, for this kind of situation also, you will find LCM. Okay. So that's what I'm giving you an example of LCM scenario. HCF I'll give you later. Okay. Let's not confuse with that. First of all, understand the LCM scenario. Whenever two things are happening at different pace and you want to find out when in future they will ring together or they will meet at the same place, this kind of scenario, you'll find the LCM.
24 minutes.
Yes, so it will be 24 minutes. So in 24 minutes, this guy would have rang, this will be ringing fourth time, but this guy will be ringing the second time only. But they will ring together exactly at the 24th minute.
The A will be ringing third time.
Oh, I'm sorry. Yes, 8 3s are 24, not 8 4s. Yes, you're right. Okay, so third time. This first bell will be ringing third time, and this will be ringing the second time. So exactly on the 24th minute, they both will ring together. So as you can see, 24 is the LCM of 8 and 12. Okay, so is this LCM scenario clear to everyone?
Yes, sir.
Yes, sir.
All right.
Yes,
Okay, very good. Let me save this, otherwise I will lose it. What lecture is it today? I think we are done with this exercise now. Let me find out if I can quickly some scenario where you might need to find HCF. Let me see if I have something ready right now. Okay. So let me give you a question which you should think whether we have to find LCM or HCF. Let's see. Okay, once you have solved this question, then I will give you some more quick tip to understand, to identify very quickly that whether you have to do LCM or HCF. Okay, so let's just do this one first. Find the maximum capacity of a container which can measure the milk of either tank an exact number of times. Okay, now go through this question, guys, and think what we have to do here. I'm saying that there are two containers, tanks, whatever it is. They have a capacity of 504 and 735 liters. That is the total capacity. And you want to find the maximum capacity of some container which will be able to exactly measure both of them. It should be able to exactly measure 504 also, and it should be able to exactly measure 735. So when I say exactly measure, what does it mean? So if I take a container which can take only 1 liter, let's say there is a 1 liter container. So it will measure this guy 504 times, right? Exactly 504 times. What about this guy? This other container? Other container, it will measure 735 times, right? Because it is 735 liters. And each time you will be able to measure 1 liter. So it will measure both of them in 504 and 735 times. Is that correct? So this would have been the perfect way. But they are saying the maximum capacity, not just this one, this
9
capacity.
liters.
Okay, so they are saying you should think of the maximum capacity. So which is the maximum capacity? Can I take 2 liter can? Will it measure both of them exactly? If I take 2 liters,
No, sir.
it will not. The 2 liter can will not be able to measure this guy correctly, no? 735, because 735 is not a multiple of 2. So what is it actually we are trying to find? We are trying to find the biggest number which will divide both of them.
HCF.
And that
HCF,
is
sir.
what is HCF. So when you have this kind of scenario where something bigger is given, 504, 735, and you are trying to find something smaller, which will multiply to equal to these number of times. Okay. So the maximum capacity of container which will measure these things will not be more than this, no? It will be lesser number, smaller number. So you are looking for a smaller number. That is a hint that you have to find HCF. Okay. So find it quickly. What is the HCF? Tell me.
3, sir.
Okay, is it 3? Is it the highest common factor? Is there no bigger number which will multiply both of them? Think about it. How? Which method did you use?
21.
Yes.
Prime factorization.
21, sir.
21.
Yes, it is 21. Okay. So now to find the HCF, you have learned 2 methods. One was earlier we learned the Euclid's division algorithm method, but there is no need to waste time with that because they have not said anything unless the question says no need to sit and use that. Okay. So just use prime factorization. What do you get? How do you write 504? Prime factors, tell me. Who has completed it?
2
cube
cube
into
into 3 square into 7.
So 504 is 2 cube, 3.
3 square into 7.
Into 7. Okay, good. Then 735, how should I write as factors?
3 into
7 square
Okay, 7 square.
into 3 into 5.
So you should write it in proper order. Write 3 first, or 3, then 5, and then 7 square. So we need to find the HCF. And whenever we have to find HCF, we look for the common factors. Which are the common factors?
3 and 7.
So 3 is
3 and
common
7.
and 7 is also there. And we need to take for HCF, what do we need to take? The lowest power or the highest power?
Lowest power.
Yes.
Yes, we have to take the lowest power for HCF. Remember that. Don't confuse with that. Be very, very clear about it. For HCF, we need the lowest power of the common. And for LCM, we need the highest power. And not only for the common factors, but all the prime factors. Okay, so it will be 3 into 7, of course, which is 21. Okay, so I'll give you one more question quickly. Let's see. Yeah, so don't, whenever you're writing question, answering for board exams, no, you should always write the final conclusion. Like whatever they asked, answer that in words over here. Make that as a habit. Okay. So 21 is HCF. They didn't ask us to find HCF. No, so 20, that's not our answer. What is the answer? You have to tell that capacity of the
21
container is
liters
21
system
liters.
HCF.
Capacity of the liters. And all of you try to do this on your own. Okay. See, now the thing is, if you people are also going to get the reduced syllabus, then these word problems will not be there for your exams. Okay.
So what is the third word? For an army,
Contingent, an army contingent of 612 members is to march behind an army band Let's look about think about this scenario. So there is an army contingent of 612 members and another there's a band of 48 members. They have to walk in equal number of columns. So that maximum number of columns will be basically the highest common factor of these two. And remember, whenever there is a question related to HCF, you will have the word maximum in that. They're looking for the maximum of something. For the LCM question, if you can notice, they're saying that after how many minutes they will meet again at the starting point. So it's not about finding the maximum of something. It's the first time when they meet. Even the bell which was ringing, when is the next time they will meet, ring together? Because they will keep ringing again and again together. Many times they will do. But when is the first time they ring together, or when is the first time they meet together after starting again? So these kind of situations, you do LCM, and whenever they ask you to find the maximum of something, usually, just of course, think about other things also. Don't just go by one single word maximum, but this will be a hint. If something they're asking maximum number of something, which will do either a column or a container size or count of something, maximum number of counts in which you can put, or boxes or something like that, then it will be usually HCF. Yeah. So if anyone has found the HCF, tell me.
12, sir.
12.
Okay, how did you write 612? Tell me.
2 square into 3 into 51.
2 square into
3
3
into
square into
51.
17.
70.
you have to be 2 square, 3 square, and 17, correct? And what is 48? 2 to the power 4 into 3. So HCF of 6, 12, and 48 will of course be, what is the common factors over here? 2 is a common factor and 3 is a common factor. We take the minimum power of both of them. So the minimum power of 2 is 2 and 3 is 1. So 4 3s are 12. So there can be a number of columns is 12. Okay. Right, so we'll take some more questions tomorrow. Anyone has any doubt from today's class? Anything? Or if there is any doubt from whatever you're studying, you can ask me right away quickly. All right then. So if no one has doubt, then I'll see you people after 10 minutes for the science class.